Okay. Now you have to find the index for t belongs to t dash, and the t dash having p comma c comma e comma f and z. Then what will the formula? Then for t equals to, we using the formula L dash t equals to minimum of L of t comma L of x plus W of x comma t. Okay. So using this relation, now we compute the smallest index from A to all other vertices in t dash using the relation L dash t equals to minimum of L of t comma L of x plus W of x comma t. So here we have take x equals to d. Here x equals to d, just we chosen in previous step. So x equal to d. Then what will the formula? The formula will be for x equal to d. The formula will be L dash t equals to minimum of L of t comma L of d plus W of d comma t. Now in this case, what is the t? T are the elements of t dash. So what are the elements in t dash? B comma c comma e comma f and z. Now you have to find the index of this one. So here, if we are taking t equals to here b, the elements will be, then what will be the formula? This will be L dash b equals to minimum of L of t, t is here b, comma L of d plus W d comma b. Because another pair here d comma b is similar to b comma d here. Okay. Then what will the value here? The minimum of, what is L of b? Just we find in the previous slide here. So L of b is, just we see here L of b equals to 22. So we put L of b equals to 22 comma L of d. Just we find this is the 8 plus, and distance between weight of d comma b. Distance between d and b is d and b. Just to see here, d and b, they are not adjacent to each other. They are not directly connected. So we put here infinity. So minimum of this is minimum of 22 comma infinity, because if you are adding any number infinity, we get always infinity. So 22 comma infinity, and the minimum is 22. So this is the index of L dash b. Similarly, we have to find the index of all other vertices of t dash. That means we have to find for c, we have to find for e, we have to find for f, and we have to find for z. So directly we can find in this c. So t equals to c here. L dash t equals to minimum of L of c comma L of d plus W of d comma c, and the index of L of c is 10 in the previous slide. Just to see, this is the 10, and L of d is 10, and W d comma c, W d comma c, d comma c, they are directly connected. So we put 10. The weight of this edge is 10. So we put here 10. Then we get L dash c equals to 10. Similarly, we get L dash e equals to, and L dash f equals to, and L dash z equals to. So L dash e is L dash e here is infinity. Why here infinity? Just we check out here. Now we're taking t equals to e here. So L dash t equals to e. So here L dash e equals to minimum of LB. So this is LE comma L comma D. This is fixed, and W D comma E. So what is the value here? So minimum of L of E. L of E, just the previous slide, the L of E is, just to see, L of E is infinity, and L of D, just we find the previous slide here, L of D is also 8 plus. Now W of D comma E, then weight of D comma E, they are not directly connected, they are not adjacent to each other, so we put infinity here. So the minimum of infinity comma infinity, we get infinity. So L dash t is also here infinity. Similarly, we find L dash f here. L dash f is 14. Similar way, so L dash, now here t equals to f here. So L dash f equals to L dash f, L of f plus L of t is fixed, and w d comma f here. So your L of a from the previous slide, what is your L of f? L of f is infinity here. L of f is infinity, and L of d is L of d is previous slide. This is L of d is 8 plus d comma f, यानी कि weight of index of d comma f. So df directly connected here, and the length of d comma f is given here. So what is the length of d comma f? We have to find. This is 8. This is 6. This is 6, and this is 3. So the weight of d and f is 6. So we put 6 here. So this is infinity comma 14. The minimum of infinity and 14 is 14. So index of L of f is 14. We have already found out. Now index of z. So now put t equals to z. We have taken here b is completed, c is completed, e is completed, f is completed. Now z. So t equals to z. So L dash z equals to minimum of L of z, or LD plus d comma z. Okay. So this is, now what is your L of z? In the previous slide, L of z is infinity, and L of t is 8, and plus w d comma j, they are not directly connected. D comma z, they are not directly connected. So we put infinity, and this will be minimum of infinity comma infinity, and always infinity. So this is always infinity. So these are the index of remaining vertices of t dash, b comma c comma e comma f comma z. Now we have to find the smallest index. So which one is smallest here? Just to see, I think smallest is c. Now we take c. Now we add the vertex c in our path and remove from the t dash. So we create another path. P double dash equals to P dash union of, here we are adding the vertex C. We are adding the vertex C here. So this will be, our path is A comma D comma C. We are increasing our path, and here, and we remove D C from T dash. We get T double dash, and it will be, the elements of T double dash will be B comma E comma F comma Z. Okay. So what is the smallest index? Now smallest index for C. So we take x equal to C here in the algorithm. Now select the smallest index in above. We our case C is the smallest index. So let take x equal to C. Now C is not equal to Z. Now C is not our final vertex. So we continue the algorithm here. So we create the new path, just we discuss here, and T dash, our new T dash is B E F Z, and new path is P double dash is A D C, and we continue in the similar manner here. So P dash we already discussed, T dash we already discussed here. Now for every vertex T in T dash, T double dash, we compute the smallest index using the relation. This is the same relation here. We have to find the smallest index for remaining vertices B comma E comma F and Z. What happened here? See. Now we are taking the first element T equals to B here. Here the elements of T dash is, first element is B. Then what will the value here? So we put T equals to B. Here will be L double dash B equals to, the formula will be changed here. Only change in notation here. In place of L dash T, we take L double dash of T equals to minimum of L dash T plus L dash D plus W D comma T, there is no change. Now L double dash B equals to minimum of L dash B and L dash D. Here D will be replaced by C. Sorry, here we are taking the C, x equal to C plus W D comma Z. So here will be C comma B. C comma B. Okay, so here L dash B, just we see, we are taking the elements B, L dash B, comma, L dash C plus W, C comma B here. So put the values, L dash B, minimum of L dash B, just to see, what is the value of L dash B, just we find. So in previous slide, L dash B is 22. So 22 comma, L dash C is 10 plus WC comma B. WC comma B, C comma B, they are directly connected, they are adjacent to each other. So this is 20. So minimum of this 22 comma 30, that is 22. That is 22. So index of L double dash B, this is vertex B in the second iteration, that is 22. Okay. Similarly, find the index for E, index for F, index for Z using the same relation here. So what will the value here? Here will be L double dash E, L double dash F and L double dash Z. So using the same concept, same relation, we have L double dash E equals to 14 and L double dash F equals to 13 and L double dash Z equals to 20. So now we have to choose the smallest index among B, comma E, comma F and Z. The smallest is 13 for the vertex Z. Sorry, for the vertex F. For the vertex F here. So now select the smallest index in the above. In our case, the vertex F is the smallest index and let x equal to F. So we put here x equals to F here. Now, what will the path? Now, adding the F in the path P double dash. So we get A comma D comma C comma F and remove F from, this is the P double dash, T double dash, and remove F from T double dash. We get B comma E comma Z. Now we have to reach at Z. That means we have to also calculate now for B, for E and then lastly Z. Okay, so our here F is not equal to Z. We just chosen this F is not equal to Z, not a final vertex. So we continue and we repeat the same procedure here. So now select the smallest index in above. In our case, F is the smallest index and x equal to F. Now we create a new path here, P triple dash equals to A comma D comma C comma F and new T double triple dash equals to, this will be B E Z.